Hello, and welcome to .NET Community Stand-Up Cloud Style. My name's Andrew Hall. I'm a program manager lead who works on .NET and Azure tooling here in Visual Studio. And with me today, I have Lisa Guthrie. Lisa, why don't you tell us a little about yourself?
Sure, I'm a program manager here as well, and I work on Azure Dev Spaces.
Cool. So when you talk about Azure Dev Spaces, tell me a little bit more about what is that?
Yeah, Azure Dev Spaces is an add-on for Azure Kubernetes Service, which is Microsoft's managed cloud Kubernetes offering. And really, Dev Spaces is focused on developer scenarios. So how can we help developers be more productive developing against AKS? And we'll be getting into a lot of the details, but it essentially allows you to develop really effectively large microservices-based applications as part of a team. You can debug your applications live in Kubernetes. You can create what we call dev spaces that isolate your code from anything else that's running on that cluster so that you're able to test really effectively what you've developed in the context of the full application.
Great. So I think we'll probably get to that here in a few minutes. Yes, so I won't ask you too many more questions quite yet.
All right.
But yeah, so for those of you joining us, again, welcome. And today, if you didn't pick it up, we're going to be talking about all things containers and Kubernetes and how you can effectively develop modern, born in the cloud microservice applications using containers and Kubernetes. And said Dev Spaces is a tool that Lisa works on, or a service that Lisa works on, kind of both, that makes that really easy and I think solves a lot of problems that people who've ever tried to have more than maybe 2 or 3 things talk to each other at the same time, hopefully will be able to relate to and understand. Before that, however, we're going to switch over and we're going to look at a couple blog posts from community members, which is kind of our tradition here. So this one is something that popped up in my feed yesterday. Actually, it was just authored March 26th. So it's a blog post by Andrew Locke. Great name, by the way. And he's talking about exploring .NET Core MCR Docker files. So let's start off by talking, what is Microsoft Container Registry? Lisa, can you explain that to me?
Yeah, it's a container registry that hosts Microsoft's official images for .NET. I believe it's mostly .NET. I don't even know if there's other things out there, but that's the main context that I use it in.
Okay, so I'm going to walk you back one step before that. Can you explain to me what a container registry is?
Yeah, I guess that would be a good place to start. So a container registry is a place where you can host container images that you've created, or obviously companies like Microsoft can host their own container images. You might, if you've been in the container world, you might have heard of Docker Hub as sort of the first or the most well-known container registry, but we also have Azure Container Registry, which is an Azure-based service where you can create your own Azure container registries. You can put whatever images that you want up there. They're close to wherever your containers are running, so pulling those container images and running them is very fast. And then MCR, Microsoft Container Registry, is just for official Microsoft images. Okay.
So, welcome back. I think what I heard you say is that a container registry is basically generally hosted somewhere in the cloud, could be on premises, but it's a storage mechanism where we can make containers available, and then anybody who has access to that registry, in the case of Microsoft Container Registry or Docker Hub, they're public, or you could have private ones, Azure Container Registry, or set up your own if you're so inclined, that then lets people who have access pull and use those images that become available.
Exactly, yeah.
Perfect. And so one of the things that Andrew talks about here in this blog post at the beginning is he talks about the idea of installing base images, which is really what most of our images available in Microsoft Container Registry is a base image. I think this is one of the things that makes containers really cool. But maybe you could start by explaining to me, what is a base image?
Yeah, a base image, it's an image that you can use as a starting point for your own images. And typically a base image will package up some things that are useful. Certainly an operating system would be the first or the most obvious part of a base image. So Linux or Windows, different Linux distributions, different on Windows Server Core versus Nano and so on. But you can package additional things into a container image, or into a base image, excuse me. So for .NET, for example, we have some that are available that are really optimized for running a production image, very lean and mean and fast. There are others that include SDKs and other components that you would use to actually build another image or to build a container out of a container. base images could also, we have base images for Node and for other programming languages that, again, just make sure that you've got everything that you need to build your application, run your application, whatever you're trying to do.
So if I was going to kind of compare this to the virtual machine world, right? Because I think one of the things that Docker tries to solve for me is it tries to solve a lot of the problems that virtual machines solved while being more efficient about some of those things, right? So isolation of applications, so anything in a container shouldn't know unless I give permissions to it to know about anything else in another container, but I don't need an entire copy of that operating system, right? So the host machine, we're going to all share the host machine's operating system kernel and things like that. So but I think one of the things that base images do that's really cool, and tell me if I'm right on this, is you mentioned that they're pre-installed with a bunch of stuff. So it would almost be, if I go back to the idea of like a virtual machine world, the ability to get a much smaller but VHD or virtual hard disk that's pre-installed with the copy of anything that I want. And these are things that are being made freely available by companies like Microsoft and other people. So if I want to run an ASP.NET Core 2.1 application, I can just go get Microsoft's ASP.NET Core 2, and it already comes pre-installed with a fully up-to-date version of ASP.NET Core. So then all I have to do is say, use this as my base image, here's my code, and problem solved. I don't actually have to go through the effort of like figuring out the install script to get it set up and to install .NET Core onto that image. Is that?
Exactly. Yeah, it's just one line in your Docker file. You can specify what image you want to pull, and it just happens. Magically, everything is there as long as you specify the correct image.
Perfect. And I think one of the things you talked about that Andrew talks about in this blog post as well is he talks about the operating system various images. And so he talks about Linux, AMD 64, Linux ARM32. And so I think one of the things that maybe to be aware of that could potentially trip you up if you weren't aware is that unlike a VHD, where you're actually bringing your own copy of the operating system, and so I could run a Linux VM on a Windows machine or a Windows VM on a Linux machine in Docker, because at the end of the day, to make them a much smaller, more efficient image, we're actually sharing the underlying operating system kernel. I couldn't run, for example, a Windows image on a Linux machine or a Linux ARM machine on or Linux ARM image on a Linux AMD 64 processor. Is that?
Yeah, exactly. Yeah, so knowing which operating system you want to pull, depending on where it's going to eventually run, is very important.
Cool. So one of the other things he talks about a little bit here, which I think would maybe the last thing that's worth talking about, is the idea of how does Docker deal with versions? So one of the things Andrew talks about here is he says you should normally be specific about which version of Docker image you want to build on in your Docker files. I don't use latest. For that reason, all the images I mentioned in the post use the current latest version, but he actually provides specific numbers. Can you talk to me a little bit about how does versioning with Docker work, and like what is the difference between latest versus a specific one?
Yeah, so typically with a given image, you will have a tag called latest, which refers to the very latest version of whatever you're dealing with. So maybe it's the latest version of Windows Server, including all the latest security patches and so on, as well as the latest version of the .NET framework. Or you can specify, depending on the tags that are provided or available for a given image, you can say, no, I want this specific version of this particular image. And the difference there comes when you specify that in your Docker file, and when that Docker file is read as part of your container build process, it will pull that image sort of real time. So if you have latest specified, and you've tested against the current latest, but tomorrow we release a new security patch for the .NET framework or for .NET Core, and that gets incorporated into the image that's tagged latest. If you were to build your container image tomorrow, it would actually be a different container image. It would be the base image would be different, because when you built your image, it would pull the very latest version of the image that you specified, and so it could auto-update. That can be good, that can be bad, depending on, ideally, of course, there's no breaking changes there, but we know that a lot of times people like to have more control over what exactly they are specifying as their base image, to make sure, okay, I have tested my code running against this specific image, and as long as I specify that specific tag, I know I'm always going to get that image. The world will not change under my feet.
Got it. So by not using latest, I'm pinning myself to one that I know that every time I trigger my build, I'm going to get the same thing I tested. Whereas latest, it just means, hey, like Microsoft pushes an update, the next time I rebuild, I'm getting something I may or may not have tested. And despite our best efforts, software turns out, especially when it comes to operating systems, runtimes, frameworks, things like that, it's very hard to change anything, even security bugs, that may not have some negative impact on some application in the world that needs to be reacted to.
Exactly, yeah.
Cool. Thank you. That's been an excellent introduction to kind of containers and container registries, which I think is a great foundational transition to this next blog post we have out here talking about Azure Dev Spaces, a free tool developing an app on top of AKS. So one of the first questions I'm going to ask is, can you just give me a high-level overview of what is Kubernetes and how does it relate to containers?
Yes. So Kubernetes is a container orchestrator. There are a lot of container orchestrators out there, but Kubernetes has really taken the lead as far as the container orchestration world goes. Now, what is container orchestration? We've talked quite a bit about containers and talked about building a container image, but in the real world, you usually, as soon as you get to any level of complexity with a microservices application, you're going to have multiple containers running. And so then you start running into problems like, well, how do they talk to each other? If this container needs to talk to that container, how does it refer to itself? And how can we make it easy as we move through from dev to test to production and so on to refer to these containers consistently? You run into problems like, what happens if a container crashes or fails for some reason? In production, how do we make sure that that container gets spun up again? How do we scale? So if it's Black Friday and we need to scale out our website to handle increased order traffic, how can we do that really easily and not sit there and type Docker run a million times to spin up additional container images? And those are the sorts of problems that a container orchestrator like Kubernetes addresses.
Okay, so I think one thing, maybe depacking that a little bit, that I heard, I think there's some concerns, a lot of the concerns that you talked about that Kubernetes or any orchestrator, Kubernetes obviously being probably the industry leader right now, a lot of those feels like concerns for an operations time, not so much development time for me as a developer. I think there's one thing you said in there that is actually very interesting for me as a developer, which is how do services talk to each other. Can you talk to me a little bit more about what is that, like how do orchestrators help solve that problem for me?
Yeah. Within Kubernetes, each service has a specific name associated with it. So if I have service A running and service B running, I don't have to change connection strings or anything like that. It's just for the two of them to talk to each other, it's just a very simple, I just say HTTP service A, and that is the way that service B can refer to service A, and vice versa. And that stays consistent as long as you're within the scope of that Kubernetes cluster. That stays consistent even as you move between different environments and so on.
Perfect. So I think what you just said there is it gives me relative DNS or domain name services, like domain name lookup. So if I have some sort of orchestrator running on my local machine, whether that be Docker Swarm or Minikube, which is a local dev version of Kubernetes, that if I write in my code or have in my config file, oh, I'm looking to talk to service A, I need to talk to service B, I can just refer to it as service B, and that'll always provide DNS for me. And then when that moves into maybe a production environment or a staging environment, as long as they're named in that environment, service A and service B, when the environment's set up, like nothing about my code or my config has to change because it's all relative within the scope of that cluster.
Exactly. Yep. And I would say that from a developer perspective, you're right. A lot of Kubernetes is about operations. In fact, in talking to a lot of developers out there, they say, I don't use Kubernetes at development time. But almost everybody has to solve that problem of how do services talk to each other at development time. And that's certainly running in Kubernetes is one way to do that.
Great. So this is again great blog post by Radu. So just shout out, give him credit. Thanks for talking about Kubernetes. So I think one of the other things we're kind of been dancing around it a little bit, but so we're talking about dev spaces. Maybe a great time to get into it. I think there's some certain challenges, and having things talk to each other is kind of the tip of that iceberg. that come with trying to develop microservice applications that will ultimately be hosted in a orchestrated container environment, Kubernetes likely, but maybe something else in the cloud. So you can talk to me about what some of those challenges are and why DevSpaces, or how DevSpaces helps me address those problems and makes developing this type of application easier.
Yeah, I think a lot of what we see, so I mean, developers generally have a great experience for getting started, coding and debugging and so on. That's not really a problem. We've been doing that for decades. Where the challenges really arise in development, or where some of the challenges that we're really trying to address with DevSpaces occur when you get your code to the point where you're pretty confident in it, developing locally. And now it's time to integrate as part of the larger application. And typically, up to that point, developers, they are running locally. We see some developers who are running, literally just using IIS Express or whatever native processes they were using before. Others who are using, for example, our container tools in Visual Studio or in VS Code to develop within containers locally. But typically, that's just the scope of one developer. So if I'm working on a feature, I'm not integrating your code at that point if we're part of a development team. I might be using mocks or stubs to simulate your feature, or maybe I am pulling your code and compiling that locally. But then that introduces challenges like, what if your code relies on a database? And how do I figure that out? How do I know what database to spin up and what to put in there? So what we see a lot is that once developers finish their code, they check it in, or there's some sort of process to get to an integration testing environment. And that's the first time where I would run my code against your code and against all of the other members of our development team. So that, again, most people have that already, but there are some challenges with an integration testing environment. It can be slow to deploy to that, or difficult. A lot of times you're relying on a CI/CD pipeline or something like that to get your code into an integration testing environment, which can take 5 or 10 minutes. And then any sort of, if something goes wrong, I mean, not that that ever happens, right? When you're integrating different components that haven't been tested together yet. But if something happened to go wrong, troubleshooting that can be very difficult, because it's hard to hook up a debugger in a remote, especially if you're running in a Kubernetes environment or something like that. And so you're relying on logs, and that can be challenging. So that's really where we think that DevSpaces can help. And what it brings is a very easy way to deploy your code into an Azure Kubernetes Service cluster and run it in the context of that full application. But you also have logs that are streamed back to your development console. We can even hook up a debugger for you with just one click. And so you get a lot of the benefits of local development, but you're not developing locally. You're developing, or you're running against your code, developing against your code that's running in the cloud and really in a more production realistic environment.
Great. So I have a couple I think follow-up questions on that. But first of all, we've been talking for about 20 minutes now. Maybe we can jump in and take a little bit of a look of what does it look like to get started with this experience?
Yeah, absolutely. So what I've brought here is a sample application that we've built on the DevSpaces team. This is out on GitHub, and we're working to package this up with some quick starts and other documentation. But I'll give you a little bit of a sneak peek here. And it's a bike sharing application. So I'm going to log in as a customer here. And I am going to, I can get a list of bikes. I can rent a bike here. So great, I've rented this lovely bike, and now I can return it. Ask me to confirm the return, and I can write a little review here. And now I'm back to my list of bikes, so I could go and rent another bike. Now I'm going to show what's happening behind the scenes here. And I'm just going to get my Kubernetes pods here. So this is running a command against my Kubernetes cluster. And once it connects and lists, you'll see that there's a number of different services running as part of this application. And there are database dependencies. I mean, this is definitely a little bit more than your basic sample Hello World application. And this is also a polyglot application. So we've got some Node.js services, some Go services, of course, some .NET.
So polyglot meaning that you're using multiple technologies to build the application. It's
exactly.
Not all .NET, not all Java, not all Go.
Yes, exactly, right. Yes, we got a number of different languages running. There we go. Okay, so you can see the services that are running in this namespace called dev. These are what make up my application. So bikes, bike sharing web, and so on. Now, and this is, so you can think of this as my integration testing environment where I've deployed my entire application from end to end. And this is really, this can be outside of dev spaces. In fact, I used just a standard Helm install command to run all these services. Helm is a package manager for Kubernetes that makes it really easy to run a big application like this and make sure that everything's in place that needs to be there for it to run successfully. So that's great. So I've got my application running, but now I've been making some changes to this reservation engine service here. And maybe I want to test them out here. So I've got the code running, or I've got the code pulled up here in VS Code. And we also have a plugin, by the way, for Visual Studio. I'm just using code today. I'm going to go and I'm going to debug just this service. And a couple of things to note here. I only have the code for reservation engine pulled up. This is a .NET service, and that's all I've got. So I don't have to touch any of the other services here. I'm not compiling them or anything like that. And when I'm debugging here, you can see in my output window here that that DevSpaces is building a container image for me. It's actually doing that up in Azure. I happen to have Docker running locally, Docker desktop on my laptop here, but it's not required. And it is then spinning up that container in my AKS cluster. And it's running in what we call a dev space. So I'm going to go back. No, this is running, and I'm going to run my kube control command again. Hopefully it won't take quite as long this time. But what you'll see here is that I still have all of my services running in that dev namespace, but you'll see another instance spun up of just of the reservation engine service that I'm debugging here. And it's running in a dev space called, or a namespace called new feature is what I called it. Sorry, I don't know why my cluster is responding slowly today, but so what happens is, there we go. Yes, so right down here, I've got this new instance of reservation engine that's running a new feature. And what happens here is that DevSpaces automatically routes requests between all these services when I use a special URL to access the site. So you can see up here, I was just on dev.bikesharingweb.blah, blah, blah. I'm going to add a prefix here to this URL. It is that space name that I mentioned of new feature. And then, of course, the rest of the URL is the same. So this is going to pull up the site again, and it looks like the exact same site, the exact same user interface and everything. But when I get in to my rent bike flow, you'll see that my browser's gonna stop here for just a minute. And I've actually hit the breakpoint here that I had set previously. So this is a live debugging session here. I can step through my code. I can inspect the values of my variables here. I can do anything that I would do if I were debugging locally, but I'm actually debugging live against AKS. Now, you might be saying, well, that's really cool, but you might be saying, Andrew, if you're on my development team, great, I'm glad you're debugging, Lisa, in the cloud, but I also need to access this site.
Yeah, I'd like my testing to not be hung up by your breakpoint, please.
Exactly. And the cool thing is that DevSpaces allows for exactly that. So I'm going to go back to the first version of the site. I'm going to remove this new feature.s here. And you'll see that when I access this version of the site now, I am accessing the DevSpaces is automatically routing requests to that reservation engine service to the one that's running in the dev namespace right here. So I still have my debugger hooked up, but you're going to see that my rent bike flow is going to work just fine here because I am running against a completely, this is actually accessing a completely different version of reservation engine. So I could break reservation engine, I can debug all day long, and I don't affect your work, the work of the rest of the team.
That is awesome. I think that to me is kind of one of the things that makes dev spaces so cool is that, unlike, I think you mentioned, like a normal environment where it'd be really big pain to get it set up to automatically route. Like I want my own copy running up there that can talk to everything else. But I want to need to be able to debug it, but you might have a dependency on it. And so really, like, you can put 2 versions up there. And so it also lets it, you can keep the stable version that you've tested, and that if I work on service A and you work on service B, and service A depends on service B, like while you're editing and testing and hitting breakpoints on your own, I'm still using the stable agreed on version of service A until you decide like this is ready and you actually promote yours out of your new feature namespace into our team namespace, right?
Exactly, yeah. And I mean, it's a huge, it's really a lot more efficient too. We talk to a lot of customers who set up something similar to this. They might have isolated environments for each developer. So you have your Kubernetes cluster, I have my Kubernetes cluster. Obviously that can get to be pretty pricey and hard to maintain. Or they have, you might have your namespace within the cluster, I have my namespace. But we have to run, we each have to run all of these services, a copy of all these services, even though, I'm just working on reservation engine and you might just be working on bikes. So here we can share what we can share, and we can still be isolated when we need to be.
One of the other things that I think is really cool, and tell me if I'm thinking about this right or wrong, but about Kubernetes and especially dev spaces specifically, is it feels like you talked about a lot of the effort I might have to go through to work in a team environment to get set up and get a project off the ground, and figuring out how to mock stuff up or figure out how to write scripts that would pull down and set up everybody's development machine to run all of the services, which may or may not even be feasible from a computing power on my local machine. And so typically the way either it is feasible and we write a script and we do it, or it's not feasible and we have to invest a bunch of effort into getting mocks or stubbing things out, or have different logic. Oh, like if I see the local development environment variable set, like just read this file in and pretend it was the results from your service or something like that, which obviously is time, and it's time that may be necessary to make me productive as a developer. But if we just start a project or migrate a project to dev spaces, it feels like, if it makes sense, we may be able to eliminate a lot of that overhead and setup. And you join the team tomorrow, and hey, just start working on this service, and it all just works as long as you remember to throw out your own namespace. Like everything's great. You're using all the rest of our services. No, PowerShell or Bash script to run to install a bunch of stuff. I'm not wasting, 3 of my cores of my machine just to run other services that I just need to test and make sure that my code works. Is that a fair way to think about that?
Absolutely, yeah. I think you have a great point about the fact that you may not be able to run everything locally. This is a relatively small application with just, I think it's like 6 or 7 services. But we talk to customers who have hundreds of services running. And that at some point you just run out of computing power on your local development machine. But you never run out of computing power in the cloud, so you can always run everything up there. And then yes, from a new developer perspective, the way that we envision this working is that you probably have a DevOps team, or maybe somebody who's inclined towards DevOps, or who's setting up what we call this a baseline, this set of services that I've got running in dev here. In the dev namespace, that is. So there's somebody for the whole team who is responsible for setting up that team's baseline. And then it is literally just as easy as new dev starts tomorrow, they're working on reservation engine, they sync the code just for reservation engine, and they're off and running, and they can do whatever they need to do. I mean, some of these services are written in Go. I don't even know Go, and I'm able to develop very effectively against this entire application, route requests through services that are running in Go without having to do anything.
Cool. I think that's actually an interesting point. You talk about the Go, which obviously is its own language, but I think going back to why are containers an interesting piece of the puzzle for solving some of these problems, one of the things even in .NET land that containers solve for me if I wanted to have a pure .NET solution is because of the way we talk about containers work, I can have different versions of .NET running in different container images.
Absolutely.
Which, I've talked to a lot of people over the years that suffer from, I call it the tyranny of the lowest common denominator, right? So I was visiting a customer a couple of years ago. They were having an issue on one of their servers, and they said, maybe you can help us debug it. And I'm like, that's great. We got a dump back, and we started trying to run some tools against some of the dumps, and I'm like, okay, well, like, these aren't working. What version of .NET was it? Oh, the server was still running .NET 4.0. And a lot of the tools that we had built since then to actually help identify the problems were required at least .NET 4.5. And I think at the time, like 4.6.2 was the current version or something, right? And so, and I said, really, why are you guys still running 4.0? And somebody wrote an application back in 2010, and we tried to upgrade the server to 4.5, and it broke, but the person that wrote it left the company, and nobody else wants to touch it or figure out how to get it to work because it's critical, and like it just works on 4. So we keep this there. And so the beauty of containers from a technology perspective, whether it's mixing Go but since we're .NET Community Standup, I'll focus on .NET, is if I want to mix .NET Core to, or .NET Framework, some things on 4.0 that these things have to still talk to, but I'd like to take advantage of some of the more modern features and security benefits and other things, I could have a container that's running the .NET 4.0 application, and I could have another container that's running the .NET 4.7.2 application, and I can use a lot of the great new functionality. And so and because of that isolation, I'm no longer tied to the tyranny of the same server either.
Right. Yeah. I mean, going back to what we were talking about at the start of this about base images and all of that, there's a Docker file. Literally, there's a Docker file for each of these services, and each one specifies a base image, and Bikes does not have to be running the same base image as billing, for example.
Can we take a minute and just talk about Docker files? Could you show me one
absolutely.
And kind of just walk through, like, what is a Docker file? I've heard the term before, but maybe you could explain it a little bit.
Yes. Let me stop my debugger here, and I'll pull one up. With dev spaces, if you're starting from scratch, if you know nothing about Docker files, we can actually scaffold a basic Docker file for you. And so you don't have to know the syntax, but it's not too hard to understand. This is what we call a multi-stage Docker file. So you'll see that means that there's multiple from statements here. And just looking at this first one, this is the base image tag, or the image tag that's used. Again, as we were talking about earlier, this one has a version number in it. So it's a ASP.NET Core 2.1 runtime image. That means that, well, with 2.2 out there, you're not going to get 2.2. It's not going to magically update to a later version of the runtime for you. And so this says that the application is going to be in this app directory. We're going to expose this application on port 80, which is very standard, your standard HTTP port, but you can certainly, we've been talking a lot about HTTP. It's probably worth mentioning that containers do not just have to be web applications. You can run all sorts of different applications in containers. With the sample application, we run a Mongo database and also a SQL database in containers. Not usually a pattern you want for production, but it's fantastic for development because you can just spin up this container. You have everything that you need right in that container. SQL's already installed, Mongo's already installed, whatever you need, and then you're up and running. So the image that's built here in this first stage of the multi-stage Docker file can then be referred to in future stages. So you see this is labeled as the actual name of this image is base, and then it's reused down here to create the final image.
So I think what you're telling me is that the Docker file is the installation/configuration file that builds my final container image, right? Is that so? So we start with a base image, which is going to, in your case, have ASP.NET Core 2.1 in it, I think. Yep. Sorry, screen's a little bit small over there. Yep, perfect, 2.1. Okay. And then you're basically in a series of steps. Then what I have the ability is I have the ability to customize it in any way that I want. So if I had some sort of weird, strange dependency for my application, I can install that into my final container image. So if I want extra config files or extra, XY, some other application that my applications are gonna have to call out to,
a library,
or whatever. Exactly. So that this is what allows me to just configure and say the final image. How much do I basically want to customize on top of the base image for my final image? Exactly.
Right. So obviously, in this particular Docker file, or sort of the one thing that you're almost always going to be doing, unless you're using something like a SQL-based image, is copying your application in, and probably building, in this case, building your application within that container. So that's a very common thing to do. But yes, there's a wide variety of customizations that you can make here too.
So if I wanted to, for example, set up a mock image for members on my team, so I wanted to say, okay, here's a, for whatever reason, all right, so let me pick an example, sorry. I'm in a world where I say, okay, you can talk to my service, but my service actually mutates data, and I don't want you mutating data while you're testing your application. But I could just create a container flavor of that, where maybe what I do is I put mock data in that it's gonna return, and that would be as part of that installation script. Maybe I just want to represent it as like JSON or something. Like I could then sort of, so okay, let me have a different Docker file to build I'll call it the handoff to friends and family for testing purposes. Is that a valid scenario?
Yeah, absolutely. Yeah, there's really, the sky's the limit on what you can do with containers.
Cool.
So I think also worth pointing out, obviously that this is text. So kind of going back to the VM comparison that you were making before, where certainly I could build a VM image that, in this case had my application in it and had the right version of the .NET framework and all of those things. But it wouldn't, there's no way to describe a VM in sort of this nice textual way. And it's hard to check that in with my code and all of that. Whereas a Docker file is all of those things. This can go along with my code. So I, as a developer, can say, these are the things that I need in this container for my application to run. I'm going to check this in with my application itself, and then it can be built appropriately at whatever phase of the pipeline I'm at.
Cool. One more question before that. I'll just quick thing to people watching the stream. Are there any questions that you may have for Lisa about containers, dev spaces, or anything like that while we continue chatting? So please feel free to ask. We'd love to answer them while we're talking. So I think going back to Docker file a little bit, so that's a standard, right? It's not, there's nothing specific or proprietary about doing this in VS Code or with dev spaces.
Nope.
It's just an open declarative standard defined by Docker. So if I go use my favorite search engine and say, Docker file hello, or how to do XYZ in Docker file, I'm probably going to find a lot of stuff out there.
Absolutely. Yes. Yeah, definitely not editor specific. I mean, it's just a text file. If VI floats your boat for editing, go for it. There's nothing Microsoft specific here. And yeah, if you have any questions about how do I do this or that, then there's definitely information on the internet. And dev spaces too utilizes these standard files. So you're not doing something that is not going to translate if you decide to move to on-prem Kubernetes or something like that, or you're running in Minikube, maybe for your local development, and then you want to use dev spaces at a future step. It's not like you're coming up with a whole lot of totally different files. There's one file that dev spaces creates that's its configuration file. It's this azds.yaml file, but everything else is really just standard Docker files, Kubernetes, Helm, the package manager, which is an open source project under the Cloud Native Computing Foundation umbrella. So all these things are very much industry standard, nothing specific to Microsoft.
So we got a question come in from our own James Montemagno. So no surprise, it's a great question. But he said, if I'm just getting started with Docker, what is the recommendation? Should I start small? Should I start with dev spaces, pods, clusters?
Yeah, where do you start? That's a great question, James, because a lot of people are in that phase where they're just getting their feet wet and figuring things out. And what I would say is we've been focused on dev spaces in this particular talk, but there's a wide variety of container tooling out there. And jumping in with dev spaces, if you're just getting started, to be honest, is probably not or may not be the best thing to do. I think one of the benefits of dev spaces, if you're just getting started, is that it does make it ridiculously easy to deploy to a Kubernetes cluster. I mean, literally, you saw with one click of a button, my code went up, it was built, it was running Kubernetes. I did not have to know any of those concepts. So if you have that need, dev spaces can be great. But if you're really just getting started with containers, I would suggest just going local. We've got great, there's great extensions for VS Code. We've got in Visual Studio, big Visual Studio, we've got our container tooling that will scaffold the basic Docker file for you. You can build that Docker image locally, you can run it locally, and so on. And sometimes that's a little easier than throwing together Docker plus Kubernetes plus Azure plus all of these concepts.
I'm going to put you on the spot real quickly, so I'm sorry. Could you give me a 1 minute or maybe 3 minute tour of how to get started with the Docker tools you mentioned in Visual Studio?
Yes, I can. The fingers crossed it all works because you are putting me on the spot, but yeah. So I'm launching Visual Studio 2019 here just because it's cool, but this is also in Visual Studio 2017. And I have, for Visual Studio 2019, I just have the Azure development workload installed. In fact, that's literally all that I have installed. And the Docker tools come with that. Dev Spaces tooling comes with that as well. So I'm going to go in, I'm going to create a new ASP.NET Core web application. And I'll call it Standup. And all of this is just standard ASP.NET Core stuff. And when I get to this screen, I have this lovely little checkbox that says Enable Docker Support. I'm actually, I can check this, but I'm not going to do that at this point. I'm going to go ahead and create my, my project just to show you another way to add Docker support to a project. But if you know from the start, you're creating a brand new project, you know from the start that you want to Dockerize it, that is a great way to go. So it's going to create the project here. Oh, and my reminders are going to pop up, even though I put on Do Not Disturb. Once Visual Studio loads here, I can right-click on that project, and there's an option to add Docker support. And what that does is just going to create a Docker file for me. Oh, actually, I just need to. I'm going to wait for my.
And I think one of the dependency while you're waiting for project to load and become available is you also, I think the tools will tell you need to do this if you forget, but install Docker Desktop.
Yeah, thank you. I do have that running down here. You can see Docker Desktop. That is a requirement for playing around with containers locally. You can use the community edition of Docker Desktop. I think it's still called Community Edition. It's completely free, but you do need to be running that, yes. So I'm going to go to Add. And then I have the option to add Docker support here. It asks me what OS I want to target. Again, this needs to, as we were talking about, you really do need to match your host OS with your guest OS for containers. In the case of Docker Desktop, it does have basically a Linux VM. It runs behind the scenes to enable running Linux containers, even though obviously I'm on Windows here. So I'm going to go ahead and do Linux. And you'll see that it's going to scaffold a Docker file for me, and it's also going to change my debug launch target here. That will be a Docker option once it goes.
We're running on pre-release bits here. I think we're pointing out. So
exactly, yes. Not even the public preview. I'm on the internal preview, so things can definitely go a little sideways. But it did indeed scaffold my Docker file here. So this is a great way to get started and play around with it. If I click, there you go, left click, then what this will do is it will actually build a container image and run that locally, hook up my debugger, just like what we saw with dev spaces. But this is completely contained on my machine, no pun intended there. So that I can get started, play around with Docker. And again, this is, if you're really just getting started, this is a much, there are fewer concepts going on here that you need to master in order to get things going. A good way to play around with containers.
I'm going to make you do one more thing. Mm-hmm. So I think when you did add Docker support, there was one other option that was relevant there, right? Which was add orchestration.
Yes, there is. So if I go back. Yeah, add container orchestrator support. We have support, I'm surprised that the Docker Compose doesn't show up in there. It should. So if I go through this flow, then I'm able to add not just a Docker file, if it doesn't already exist, but also add a Helm chart for this particular project that I can use to easily deploy that to a Kubernetes, and any Kubernetes cluster, because Helm is, again, a Kubernetes standard. It's not a Microsoft or an Azure thing. And also, it also adds files so that I can run this very easily in dev spaces if that's the direction I want to go in.
Well, so I think even though you're missing it here on the internal preview, which is a bug we should go get fixed.
Exactly.
I'm going to make an assertion that I think for most people, going back to James' original question, how to get started, I'll kind of talk about my own experience a little bit, and then you can tell me all the ways I did it wrong. I think actually Docker Swarm is the easiest place to get started with locally. And I think if you're really trying to get a feel for learning about Docker, probably the best way to get started is to actually add that orchestration support, create maybe 2 little services that you want to talk to each other, and then use the extra file that comes in called Docker Compose to kind of structure and then you start to learn those, like, hey, like I can change the ports that this is exposed on the Docker file, and I can name this in my Compose file, which creates my little mini cluster, and now I can see the relative, like, oh, I can just call Web API A or Web API on project B from project A, and I can just use HTTP from service B or whatever, and even though we're bug here in internal preview of 2019, I think it's worth pointing out all of this stuff works on Visual Studio 2017 as well, which is of course the one in the market that's stable that I'm assuming most people have. So I think that's how I really learned and started to get a feel for container orchestration and things like that.
Yeah. And that's not wrong. I think it's a dirty little secret that most of the people I talk to who are developing for Kubernetes are still using Docker Compose locally. If they're doing some sort of orchestration locally, for many of the reasons that you mentioned, that it's very simple. It gives you, really it's that inter-service communication that people need for the most part. Of course, you talk to some folks who are doing really complex stuff with Kubernetes where it's important to have more, but to a getting started question, I don't think you're wrong to start with Docker, just Docker containers locally. The experience that we scaffold initially is very, very simple, where it's just a Docker file. You don't even have the extra layer of Compose. Once you're comfortable with that, Compose is a fine choice for when you start wanting to see the magic of, wait, I just write HTTP my service name and it works. Like what is that about? Compose really gives you a good experience there.
So I'm gonna make you do one more little plug, because this is obviously Cloud Tool Standup. So let's say I've done what you've done there, so we can back out of the add orchestration support. And I really would like to test, hey, I wrote this container, it seems to work locally. One of the promises of containers that we didn't talk about a lot in the beginning, but is in theory, whatever I run locally should be exactly the same, like it should be an immutable image, just like an executable. So when I move it into the cloud somewhere, it should be the same thing. If I wanted to try this in Azure for my own development machine, really, really quickly, how would I go about doing that?
Yeah, so what I would recommend, there's lots of Azure services out there that can run containers, maybe even too many Azure services out there that can run containers. Obviously, as the dev spaces PM, I'm a huge fan of Azure Kubernetes Service and think it's the best way to run Kubernetes. But if you're just getting started, again, it can be really overwhelming. Thankfully, you can run containers in app service as well. And that's a much simpler experience.
So to get there, I think I would just have to right-click on my project, right?
My Docker is not configured right. But yes, I can
choose Publish.
Yes, go to right-click and Publish. And there are all sorts of different options here. I can publish, we were talking about container registries earlier, and I can publish directly to a container registry. That would be probably a little bit further down the line when I've got my code running well and I'm ready to really package that up on the way to production. But a really great way to just test and get started is to do the App Service Linux option. And I can publish there. It offers, I can write in Visual Studio. I don't have to go out to the Azure portal. I can create a new App Service Linux instance here, and I can just publish right up to that.
Perfect. And then I think if we just back out of this real quick, I think the kind of the last aspect of that then would be going back to this is, you mentioned if I wanted to try Kubernetes or I wanted to try Azure Container Instances, ACI, the reason we have the container registry there is once I publish it to that Azure Container Registry, we also support Docker Hub or Custom, so we're not limiting you. But then you could, via generally other command line tools, Azure CLI or something else, then go to try it in any other place in the cloud that works with containers. So we have a really nice smooth experience that you showed for, hey, if it's you're using a Linux base image with an ASP.NET Core application, go, one click, done. It just goes up to App Service. You're running your own copy of your own container in App Service Linux, and we do all the wiring up between the container registry and the App Service Linux. But if you want to try it anywhere else, just publish it to a container registry, and there's actually some really great tutorials online. For example, before dev spaces existed, I was like, hey, I want to go check out what this AKS Azure Kubernetes thing is, and I was just copying and pasting out the tutorial into my Azure CLI. The only difference is I created my app, I published it to container registry, and then you just need the registry URL, which we actually put on the summary page after you're done, and then you just paste that into the CLI, and then it was actually able to go try AKS from Visual Studio with just Visual Studio and the Azure CLI.
Exactly. Yeah, I think of container registries as like the universal donor. So once stuff is up there, it can go to just about anywhere you want. That's really just a real standard. And Docker Hub, Azure Container Registry, they all have ways or any service that utilizes containers is going to have ways to pull those container images from one of those registries. So from Visual Studio, you can get your code up to that registry, and then it's really easy to pull it in wherever you want.
All right, so it looks like we don't have any more questions online. So Lisa, I want to thank you for joining us today and teaching us about all things container and dev spaces.
We had one about VS 2019 as this new VS 2019, and yes, it is. But everything we have showed is available in the new VS 2019, which is out. You can get the release candidate, download that if you want to play around with it. But it's also all available in Visual Studio 2017. So as long as you're on a reasonably recent build of VS 2017, you've got access to all this as well.
And I think, and I'll just kind of do the last little plug. So the question, the flow because we have a nice thing up here that shows us streams comments from different sources. If you're not seeing it, somebody said, is this the new 2019? James said, yeah, it is. And then eBlack TV said, sweet, when is it leaving preview? We have publicly announced this, so you can already go sign up to watch our keynote and live stream events that correspond with the release 2019, and that will be on Tuesday. So this coming Tuesday, April 2nd, Visual Studio 2018 will go RTW. It will be GA, and there are an entire series of events that day, starting with a great keynote by Scott Hanselman, where he's going to give you a great behind-the-scenes look at the team that built it, that plugged, and then there'll be a series of live streams all day talking about various new things in 2019. So if you want a deeper dive on things like the debugger or the cloud tools or live share or IntelliCode or how to be more productive developing your applications, there will be half-an-hour sessions that you can tune into all day. Last thing, just a reminder, we do these stand-ups every Tuesday and Thursday. So Tuesdays are, I believe, ASP.NET stand-ups. Thursdays are a rotating schedule of .NET things. We do cloud, that was this week. We do mobile, we do .NET tooling, and we do .NET runtime. So be sure to subscribe. You can subscribe on YouTube or Twitch, wherever you prefer to watch. Thank you, everybody. Have a great day.
Thanks.
Cool. Thank you.
Yeah. Why is Docker Compose not there? That's funny. Yesterday I was actually trying to get that sample to run in Visual Studio. I didn't want to use code, but I couldn't get it running in Visual Studio because Kubernetes and Helm wasn't in the dropdown, but Docker